Hello everyone, welcome to my YouTube channel. Thank you so much for your amazing response, valuable feedback and comments. As you know, I'm doing regular podcasts on quantum computing. So today we are going to discuss one of the most important aspect of quantum computing, that is all about how to build a career in this area. Building a career in the sense there are so many prerequisites. What programming languages the student should learn, what kind of ecosystem they have to build in their own career to be equipped with the talent that the industry wants. All these points are there in everybody's mind. Do I need to learn maths? Do I need to learn physics? How to proceed further in this quantum computing area? This is what is the major doubt with many students, many professionals that I have come across. So today we have an expert in this area who is doing very good in this quantum computing area. That is none other than Rikteem. So Rikteem is the head of quantum communications, who is spearheading entanglement-based QKD systems. We are very happy to have him, and his expertise in this area definitely going to help us a lot. So, not wasting your valuable time, I want you all to listen this podcast from beginning to ending. Do provide your valuable comments, and also do share this podcast to your near and dear who are very much enthusiastic in the quantum computing area. So thank you so much, Ritin, for joining this podcast session and accepting my invitation. I know you are very busy. Even then, you have accepted the invitation and joined this to spread your knowledge. Can you please introduce yourself to my audience?
Yeah, thanks Rajesh for this very nice introduction. I think you gave a very good start. So I'm Riktim. I work in quantum communications domain particularly and focus on quantum computing and sensing as well. I'm part of Quantum AI Global and Q Labs, and I had the quantum communications wing there. And it's been around 6 years since I have been to this organization. And talking about my background, I come from a physics background. With a theoretical physics background, and then coming into quantum and developing the quantum hardware and software solutions. So I think, yeah, it would be a really good discussion to share my insights into this field. Yeah.
Thank you so much, Ritin. All these points which I have mentioned, and it will be very useful for all the students who want to enter into this field. Starting our podcast discussion, Ritin, what core skills should students build first to enter the field of quantum communication? Is it physics, maths, or programming?
Okay, that's a very interesting question, the first one itself, because in my opinion, it's an interdisciplinary field and it's not just physics or maths or computer science particularly. Like from my experience, I've understood that people from all different backgrounds are very much required. Like we need people from electronics, we need people from math background, from crypto side, cryptography side, from computer science, and from physics definitely. And also people from chemistry are very much encouraged to be a part because it's an interdisciplinary field, and in quantum itself we have like four divisions: communications, computing, sensing, and materials. So there are like different people can contribute in a very meaningful way.
Which programming language are most relevant for quantum communication? Is it Python or languages like C++, MATLAB, or Julia also are used?
Okay.
So, what do you think? Which language they have to enter and they have to
Mm.
expertise,
Well, I
especially?
think because of Qiskit by IBM, because of IBM particularly, Qiskit has become very popular, and that uses Python mostly. And Penguin also by Xanadu, Xanadu's Penguin. So I think Python is a very good start to have, good to have. That's for the high level programming language. But again, if you the more you enter into this field, more programming languages become important, because when you go for system level designing or soft designing, C++, then MATLAB designing, LabVIEW, this will be very good programming skills. So I will say Python is a good to start, but again, the more you go into the field, more programming languages come up. Then again, I can recall about electronics side, like for doing FPGA programming, you will need something like Verilog or VHDL programmings. So there are different parts. And again, when you want to do productize some of this, basically bring some of these products to the users, so you have to do some full stack development also. So we do need people from those backgrounds as well. So again, not particularly Python, but again, very different skill sets are required.
That's very nice. What are the most widely used quantum programming frameworks and toolkits today, such as Qiskit, Kirk? QuTiP, or others, where should beginners start actually?
Yeah. So Qiskit is a very good start, I would say, because it gives a very wide perspective to the students. Then there is Bracket by AWS. So Bracket is also a very good platform because Bracket will help you to interface with many different quantum computers, from superconducting to trapped ion to some neutral atom computing systems also. So Bracket is again a very good interface. So I would say knowing Qiskit, or if you are going for physics-based simulation, or for example open quantum systems or noisy system simulations, then QTIP is a very good tool. So I would say knowing Qiskit is a good Qiskit, then Bracket, then QTIP would be very good to start.
Super. Beyond coding, what simulation or photonic design tools are essential for those who want to design entangled photon sources or QKD systems?
Okay, so if you talk about simulations, then there are some simulation tools like optics simulation tools, like one by Zemax 3D Optics, then ANSYS Numericals. Then there is one more by COMSOL's Multiphysics. So these are some of the tools where you can design the basic entities, like maybe the hardware which is used to develop entangled photons. But I would say like it's really hard to mimic quantum physics because these CPUs don't give you that level of computing power to actually simulate the quantum physics or maybe the Schrodinger equations per se. So that those are some of the good tools to start with. But again, if you want a real flavor, definitely you have to go to the real hardware. But again, if you want to do QKD or communications, which is on the entanglement photon side, or entanglement based systems, then you can go with some of the quantum network simulator tools also, which are freely available. Like you can go for Sequence or NetSquid. They are little tough to work with because if you don't have a good understanding, you will struggle a lot to install and then get your hands with. But I think having like dwindling it with for some time, you can get a good idea. So quantum network simulators are there, and then optics simulators, those can be some of the tools to begin with.
Okay. So, how can students practically learn to simulate entanglement, quantum states, and key distribution using open source platforms or cloud based quantum labs?
Okay, so again, like I said, simulation, uh, using this, the previous answer was also similar on the similar lines, like using some of this quantum network simulators, you can start your get your hands dirty. And if you want to do some quantum, like for example, quantum entanglement, do it on real hardware, then you can design. I think there is some noise, right? Yeah. Okay. All right. So whereas I was talking about some of the real things, right? So what we can do is we can, like for example, if you want to do some quantum entanglement and get it on the real hardware, then you can do some circuit designing and get your jobs run on Qiskit or IBM quantum platforms, because they will provide you real quantum hardware access. So doing that, you will know like what exactly, how exactly you can work out with the real stuff. So I think IBM Quantum Platforms gives you a real access because you don't need a hardware on your own side, and you can remotely connect and get your quantum jobs executed and get the results out. So that can be a good start to see like how quantum things come in picture, and how the quantum noises or different aspects of quantum play in the real. So I think that can be some good start to simulate quantum entanglement.
Especially, there are some students who are very much interested in hardware. What hands on design skills are needed in optics, photonics, and electronics to build quantum network components?
Yeah. So now we are coming to the real questions, because I personally feel that simulation will only take you this far. Like it won't get you to the real part. So knowing the real hardware, how things work, like we say, entanglement is just like two particles getting, they are like twins. And it's very easy in theory. It's just one line equation. But getting it in the lab, it's really difficult. Like you will never know like when mixed states are dominating and when quantum entanglement is coming. Like the classical to quantum transition, to get it in the lab is it's really tricky. So I guess uh, having some hardware experience is definitely a very plus point. And what expertise, I wouldn't say expertise, but experience is good to have for knowing hardware would be like some optics based experiments, like where you know how to work with different crystals, type of crystals, different kinds of lasers, then different optical components like wave plates, mirrors, and then how to mount, how to design some optical setup in the as a tabletop experiment, and to get to the results, like how do you characterize the experiments. So these are some of the good things to have. And then uh, because quantum communication is all about, like if you go for fibers, or it can be either fiber or free space based. So in quantum communications, if you are interested in that side, then I would say knowing about working with optical fibers, how to work with multiplexing, and then signal transmission, signal processing. This would be some of the core hands-on skill sets.
How important is interdisciplinary knowledge, combining software, hardware, and quantum theory in becoming a complete quantum communication engineer?
I would say that's a golden skill. Like if
Okay.
someone has everything, like some software knowledge, then some hardware knowledge, that's a very plus, very good to have thing. But definitely, for freshers or for people who are starting it for the first time, definitely we don't expect also people to have everything. But it's like you should know some, you should be master of one skill, either on the software side or from the hardware side. And once you, for example, if you are good with the software side because that's easy to access, then you can slowly transition your knowledge from the software to the hardware side. So I would say if someone comes with both this knowledge, then that's a definitely very advantageous skill, because they will be the uh, uh, initiators in the future who can migrate the systems from the classical to the quantum region.
So, what kind of roles or jobs are emerging right now in the quantum communication industry? Because you are the CEO of the company, you are heading the organization. From software simulation engineers to photonic designers and system integrators, what kind of job roles are presently in the market?
Yeah, yeah. So like I'm the head in the quantum communication. So I've had this experience of getting to know a lot of different people from a lot of different background, and we do have a versatile team in our organization also. So I would say there are a lot of different kinds of roles. For example, the easiest is software side. So we do have requirements from the full stack development side, from the back end and the front end itself. Then we do have, from communications perspective, we do have requirements in cryptography side. Then there are system integrators. For example, the people who will be integrating these quantum devices into the existing hardware stack, right? Then there are demands from photonic integrated circuit designers. These are like chips, small, very small chips, which integrates optical components. So you don't build a very big setup, and but you can miniaturize and do everything on chip. Then there are semiconductor chip designers who are very much required, and then electronics engineer, never to say. Like they are one of the most demanding guys in this entire thing, in this quantum, because in quantum it's like everything behind the screen is all classical. Because why classical? Because we do work with like electricity. We'll have voltages, different voltages to tune the parameters, different form of signals, different form of modulators, demodulators. So these are some of the very common things which is actually existing, and and having a good knowledge of that, designing quantum systems become easier.
Yes. How are organizations like Q Labs and Quantum AI Global shaping talent development, and what to do? What do they look for when hiring quantum engineers or researchers?
Well, I would say what we did in the past. So we did couple of training programs online where we trained around 300 to 400 students from various backgrounds. We didn't just take physics guys or CS guys. Like, it was an open invitation where we trained everyone for free. The idea was to get them some general idea of quantum, awareness, particularly awareness, and then based on the interest, take them to advanced courses. So advanced like quantum communication, specialization, or sensing. So how it helped us was uh, getting these people ready. Uh, One thing was they were ready for the market now, like for the industry particularly, because they have some knowledge, maybe not the very experience in this area, but they have some knowledge about like what is happening. So that's a very important question. Like if people know like what is happening, then it's easy to track down the progress, right? So
Yes.
that's one thing we did in the past, and also that helped us with our resource requirement also, because the people we trained, we were confident on them because we know how they've performed. So some of them are part of our team also today. That's one thing. Then what else we do is like we go into different colleges for quantum awareness programs. Like we specially target some of the colleges and universities in tier 1 and tier 2 cities, so that we can make quantum awareness into their organization, get their students or the btech students know about the quantum, and then meaningfully contribute. Because when people start in quantum, it's only just they think about its computing, or maybe they have heard about communications, but it's an interdisciplinary field. And that's what we want, that's what we also go and preach in these institutes, that people from different backgrounds are welcome. And it's not like AI that you need a CS background, or for example you just need an AI course to work with quantum. So we do need people from different background, and we encourage people that whatever your core skill set is, master that, because that can help with the industry in a very meaningful way.
Okay. Coming to your journey, Rikteem, you are heading one organization. So, how was your journey? So, what were the challenges you have faced as a person who is heading the company? Can you please share your own experiences?
Yeah, so I will say it's been quite a rough journey for all of us, like from our CEO to all the people. Why rough? Because quantum is a very new field, and it's not easy to understand. That's the first bottleneck. And when we say not easy to understand, it's difficult to convince also. Like by the time people start to understand the importance, we see like there are a lot of other people who are in the market, coming up in the market. So definitely the competition is very much, even though it's not visible to the direct people. But I will say it's been a very interesting journey, because now after 6 years, more than 6 years in this organization, and building this organization together with all the people, we have come a lot far. And now we have some very good we have very good understanding of the market, the demands of the market. I would say it was a gestation period for us, where we have like developed some good knowledge about how the market would react, and how what could be the meaningful products in the market, and as well as having a very good team now. So I think we are right in the right position right now to take up this challenge of quantum and build something meaningful for the country.
To know about that. How do you think is the present scenario, like for the global point of view, from the global point of view, India point of view? What do you think the present quantum computing state is? Because I am seeing students are joining BTech course, MTech course, even they are doing some research work in this area. So, how do you foresee the coming days for quantum computing?
The quantum days have just started, I would say, because
Okay.
in India, with the push from National Quantum Mission and various government initiatives, uh, encouragement has become very much high, I would say. And not just from academic side, it inspires the industries also, because academics would do the fundamental research, and um, the industry would take that research and make it into useful products which can be used for the common people, right? So some people may perceive it as that India had started late, because the western side have actually done some very good progress in this. And but the way we see it is India is not late, I would say, because India is right at the right moment right now, because we have seen like how things have failed, and we don't have to repeat those mistakes. So we get that upper hand right now. And uh, with uh, with all these national initiatives, I think it's a very evolving field, right? Evolving field. And there are a lot of opportunities which will come in the future. Like, and I would say future is today, because like we see a lot of applications flooding in, and we do have like lot of, like if you just open LinkedIn, you will see every other company is posting some success that they have been recognized, they have got some new discovery. So I think definitely with quantum, it won't be the story of semiconductor that we faced in the past decade. With quantum, it's definitely a new story, and India is very rightly positioned to take up the global challenge.
Yeah, it's very good to know and very good for the students as well. Now, coming to the last point, looking ahead, how will AI, quantum computing, and quantum networks converge? And what new job profiles will this create for the next decade?
Yes, the last part was important next decade, because it will take some time, because quantum computers becoming meaningful, it has just started. Like the qubit sizes and noticing quantum advantage, quantum supremacy, these things have just started now. So I would say there's still time, maybe half a decade or maybe more. Then when we see that AI solutions can be integrated into with quantum power. But what I can foresee already is also with some of the POCs that we have worked on. That's how our company's name is Quantum AI Global. We are trying to integrate both these solutions. We have seen that it's very powerful, because with the power of AI and with the power of quantum computing's capabilities, some solutions in the optimization domain, in the logistics domain, it can be very powerful. In the machine learning also, it can be really very powerful. But immediately why we don't see such products in the market is because quantum computers have not become very meaningful right now, because of the qubit sizes and the noises. But that's just like 2 3 years down the line now, when we can definitely see some of the good progress from quantum. And I think it would be that time, then at that time when we see quantum and AI getting merged, and some new very interesting solutions or products will come out.
Yeah. So,
I
we
would
hope the
say,
best.
yeah, I would say like that's the future. Like
Yeah.
definitely, that has to be the future. There's no other way.
Yeah. That is really great to know about that. And Rikteem, thank you so much for your valuable time. You have really given the valuable insights for all the students who have entered into this field, because I get many inbox messages asking me like how to develop in this area, what to do, what can be the best path for us. You have cleared many points for those eagerly waiting students. Thank you so much for your valuable time. And here it's very good to have a conversation with you.
Equally, same Rajesh. Like the questions were very meaningful. I think people hearing this podcast, they can get some good benefit out of it.
Yeah. Thank you so much, Rikteem.
Yeah.
Thank you.
Thank you so much.